right, so what we're going to do is we're going to start proving triangles by certain things. We only need, we talked about how there's six angles and that are in between two triangles and six sides. And if we can show that the three sides are congruent, the three angles are congruent, then the two angles are congruent to each other. Technically, we only need to have three parts. And we're going to learn about some of them, all right, as we go through this chapter. The first one that we're going to talk about is called side angle side. So the included angle of two sides of a triangle is an angle formed by the two sides. So if we look right here, angle B is the included angle of side AB, which is already marked, and side BC, which wasn't marked. So I made it with three tick marks. All right. They gave us angle A was already one. And you could also say that angle C, you could say that angle C is also an included angle of line segment CB and line segment CA. So again, if I mark that one, all right, so that's what they're talking about included. It's in between the two marked ones. So the one that we have actually, right, is we have angle A is included from AB and AC, and angle D is included in DE and EF. And then that what tells us is the theorem tells us if two sides of an included angle of one triangle are congruent to two sides in the included angle of a second triangle, then the two triangles are congruent. So what it is saying there, ladies and gentlemen, is it says if, I'm going to write it down in symbols here now, if AB is congruent to line segment DE, and we know that angle A is congruent to angle D, and line segment AC is congruent to line segment DF. So I just told you we only need three parts to show that triangles are congruent. So these are our three parts, then we can say that triangle ABC is congruent to triangle DEF. And again, because if you look at it, we just did it by side angle side. So that's kind of what these two, I just have two quick examples for you. So what can you conclude about triangle ABC and triangle DBC if you know that B is the midpoint of AD? So we know that B is the midpoint of this line segment here, right? So we know if it's the midpoint, we know it's going to cut that line in half. So we know that this segment here is congruent or equal to that line segment there. All right. So what I just said, if B is the midpoint, then AB is congruent to line segment BD. Line segment. Okay. Now, what else do you know? You know that angle ABD is congruent to angle DBC. ABC here, my bad. Sorry. That's what happens when you do stuff at midnight. So angle ABC, so that's that one right there. and then DBC, that one's right there. We know that they're congruent. Why? What kind of angles did they make? We got the square there. So what kind of angles do they are right angles, right? So because they are both right angles. Okay. And finally, you know, so look here, you've got a side, you've got an angle. We want that angle to be included, right? So where's it going to be included? Well, if I can state that this one right here is the same, all right? Remember, I just told you that reflexive property, and we're going to keep using it. I can say that BC is congruent to itself, BC, because it's by the reflexive property. All right, so now I just showed you that three things happen. So now we can state that triangle ABC. Now again, look at how I went. I went through the one that is marked once. I went through the right angle, and I went through the one that is marked with two tick marks. You have to follow the same path, ladies and gentlemen. So I'm going to go D, B, C. I followed the same path through the one tick marked once to the through the angle to the one marked twice. So triangle ABC is congruent to triangle DBC. And again, by what I just told you, by side angle side. We're going to see a couple of other ones as we go on. We're going to see side, side, side. We're going to see angle, angle, side. All right. So some of these are going to be important for us, but they started us off with one that we can always all see. So sometimes I'll ask you to determine whether there's enough information. On both of mine, I just decided to call it what can you conclude. All right. But I know on some of the homework, you're going to say, decide whether there's enough information to say that they're congruent. Right now, all you know, ladies and gentlemen, is by side angle side. So on example 2 here, what can you conclude about triangle PTS? So that would be this one right here, and triangle RTQ. Okay, now notice what we did. We went through the one that is marked 1. We're looking at that angle, and we're not going to call it just plain angle T, ladies and gentlemen, right? Because there's more than one angle T there. There's actually 4 of them that have T in it, so it has to be the middle of them. And that's what it's showing you right here, T and T. So you can tell me that you know that those two angles there, if I know what those are, if they're congruent, then I can state that those two triangles are congruent by side angle side. Well, you know that angle, and again, I'm going to call it angle PTS. I know it is congruent to angle RTQ. Why? What kind of angles did they make? Think of all the ones I've talked about. Are they corresponding angles? Are they alternate interior angles? Are they Co-interior angles, are they vertical angles? Yes, they're vertical angles. So we can say that they're congruent since they are vertical angles. All right. And then the other two things were marked, so I don't really have to write it down. If I was making a proof, I would have to write it all down. But since we already know that P is the same, PT is the same as RT, and TS is the same as TQ, we can just say that triangle PTS is congruent to triangle RTQ because we were given enough information. On the first one, I had to kind of show you a couple other things, but that was it, ladies and gentlemen. The homework should be pretty quick too.